Thanks for watching my video today. Let's introduce our partial derivative. Okay, so ordinary differentiation is denoted by d, right? D by dx. And for partial, so partial derivative. Okay, now let's define that. What is meant by partial derivative? So if you talk about partial, okay, so partial means it considers two variables or three variables. Okay, more than one variables. Okay, for partial. But for our ordinary, we just consider only one variables only. Okay, but for partial, there are more than one variables. Okay, so our partial derivative definition is nothing but the result of differentiating u equal to f of xy. This is what I mean, right? This we have two variables, more than one variables, right? So u equal to f of xy with respect to x, treating y as constant, is called partial derivative of u with respect to x and denoted by this one. Okay, this is we pronounce in as del. Okay, so del u by del x or del f by del x, or sometimes this or this we denote it by fx. Okay, of xy, or just fx. Okay, or just ux only. Then this or analytically der f by der x, then is our partial derivative of f with respect to x is nothing but limit delta x tends to 0. Delta x is nothing but increment. Okay, just increment. So f of x plus delta x comma y minus f of xy upon delta x, if limit exists. Okay, if this limit exists, it means. Okay, this is our definition for partial derivative with respect to x. Okay, and similarly for with respect to y, then you get limit delta y tends to 0, f of, here we treat x as constant. Okay, so x comma y plus delta y minus f of xy upon delta y, if limit exists. Okay, meaning if this limit exists. Okay, if this limit exists. So this is our definition for partial derivative. Okay, now let me give you an example for this types. Okay, so for example, if you take u equal to ax squared plus 2hy 2hxy plus by squared. Now we are going to differentiate with respect to x, treating y as constant. There u by there y there x is nothing but a times there by there x into x squared plus 2hy, right? So this whole term are constant with respect to x, so there x by there x plus there by there x by squared. So which is one is this is same as our ordinary differentiation. So d by dx of x to the n is n x and minus 1, right? So this will be 2 times 2ax, right, plus this is the differentiation of partial derivative of x with respect to x is just 1, so 2hy, and this is derivative of constant, right, is just 0, therefore you get this. Now with respect to y is similarly you get 2hx, right, this is 0 because differentiation of constant is 0, and 2hx plus 2by. So okay, so this is how we differentiate these types of partial derivative. Okay.